Hello students, welcome to Anne's classes. Let's do Exponents, Chapter 2, Exercise 2A. This is found on page number 33. So let's begin by studying some of the laws of exponents, some of which we have already done and you know about it. The first one is the product law. When the base is the same and we have to multiply, then in that case, what do? We add up the powers. Now let's take an example. Now suppose we have 2 to the power of 3 into 2 to the power of 2. So what does this become here? Can you see the base is the same? Both are 2 and this is multiplication. So when the base is the same and it is multiplication, we add up the powers. So this becomes 2 to the power of 3 plus 2, which is 2 to the power of 5. And then we simplify this and get our answer. So this is the product law. Now we have the quotient law. So in multiplication, we add the powers. In division, we subtract the powers. So if I take the example of 5 to the power of 7 divided by 5 to the power of 4. So this becomes 5 to the power of 7 minus 4, which is 5 to the power of 3. So when it is multiplication, we add up the powers. When it is division, we subtract the powers. So this is the quotient law, which can also be written like this. So this also means the same, that it is division where we subtract the powers. Then we have the power law. Power law is when a base is raised to a power and that whole thing is raised to another power. So in that case, we multiply the powers. Now here, if I have 3 to the power of 2 raised to the power of 3. So this becomes 3 to the power of 2 into 3. That is 3 to the power of 2 threes are 6. Next, we have the negative exponent. So here can you see the exponent is negative. If the exponent is negative, then we write it this way. So how was it? Now suppose I have here 4 to the power of minus 2. In this case, I write 1 by 4 to the power of 2. Now the power becomes positive. So 4 to the power of minus 2, I write it as 1 by 4 to the power of 2. And when I have a positive power, now the same thing, suppose I have 4 to the power of 2. Now if I have to write it this way, it becomes 1 by 4 to the power of minus 2. So this is in the case of negative powers. So here if it is minus 2, the power is negative, then we write it this way. Power is positive, and if you have to write it this way, then it becomes negative when it goes down. Question 1, evaluate. In the first one, we have 3 to the power of minus 1 into 9 to the power of minus 1 in brackets divided by 3 to the power of minus 2. So what is given in brackets has to be done first. And here we have 3 to the power of minus 1. So let's work out what is within brackets first. Now here, this is a negative power, isn't it? And we have learned that 3 to the power of minus 1, or if I have to raise this to a negative power, as we saw in the laws of exponents, a to the power of minus n will be 1 by a to the power of n, where the power becomes positive. So 3 to the power of minus 1 will be 1 by 3 to the power of 1. The power becomes positive. So let's write that here. So this becomes 1 by 3 to the, that is 1 by 3 to the power of 1. Similarly, now into 9 raised to negative power will become 1 by 9 raised to the power of 1. So this is within brackets. Division, here we have 3 raised to the power of minus 2. The power is negative. So now we're going to make it positive by writing it this way. Now we can work out. So here it is 1 by 3 into 1 by 9, because 3 raised to the power of 1 is 3, 9 raised to the power of 1 is 9, divided by 1 by 3 raised to the power of 2. So here let's work out what is within brackets here. So multiply the numerators and the denominators. 1 into 1 is 1 and 3 nines are 27. Divided by 1 by 3 square means 3 into 3. 3 threes are 9. Now we know how to do division of fractions. So this becomes 1 by 27. Division changes to multiplication. Then we write the reciprocal 9 by 1. Now we can cancel 9 and 27. 9 ones are 9. 9 threes are 27. Now multiply the numerators and the denominators. 1 ones are 1 and 3 ones are 3. So what is our answer? 1 by 3. Question 2, here also let's work out within brackets what we have there first. So 3 to the power of minus 1. So again it's a negative power. So we're going to write this as 1 by 3 to the power of 1 into, again we have a negative power, 4 to the power of minus 1, which we write as 1 by 4 to the power of 1. Divided by 6 is raised to the negative power. So again 1 by 6 to the power of 1. So this becomes 1 by 3 to the power of 1 is 3 itself into 1 by 4 to the power of 1 is 4 itself. And this is divided by 1 by 6. Now let's work out, multiply the numerators here and the denominator. So you get 1 ones are 1 and 3 fours are 12 divided by 1 by 6. So this becomes 1 by 12. Division changes to multiplication. 1 by 6 becomes 6 by 1. Now we can cancel 6 and 12. 6 ones are 6 and 6 twos are 12. So 1 into 1 is 1 and 2 ones are 2. So our final answer here is 1 by 2. Question 3, 2 raised to the power of minus 1 plus 3 raised to the power of minus 1 and the whole is raised to the power of 3. So let's do this part, that is 2 raised to the power of minus 1. It's a negative power. So this becomes, remember it's still in brackets, 1 by 2 to the power of 1 plus 3 to the power of 1 will be 1 by 3 to the power of 1 because it's minus 1 there. This has come to the denominator. Now this is raised to the power of 3. So this is 1 by 2 plus 1 by 3. So this is 1 by 2 plus 1 by 3 and the whole thing is raised to the power of 3. Now 1 by 2 plus 1 by 3, they are fractions. That means we have to add up the fractions by finding the LCM. So LCM of 2 and 3. So let's do that quickly. 2 ones are 2 and then you bring down 3. Then 3 you have here 1 and 1. 2 into 3. 2 threes are 6. 6 is the LCM. Now here let's have the LCM here 6 and 2 into 3 is 6. So 1 into 3 is 3 plus, go to the next denominator, 3 twos are 6. So 1 into 2 is 2. So 3 plus 2, the whole thing raised to the power of 3. So 3 plus 2 is 5. 5 by 6, this whole thing is raised to the power of 3. That means we have to multiply 5 3 times. 5 into 5 into 5. And we have to multiply 6 also 3 times. 6 into 6 into 6. So first 5 fives are 25. 25 fives are 125 by, now let's multiply these. So here it will be 6 into 6 is 36. 36 into 6 is 216. So our final answer here is 125 divided by 216. Question 4. Question 4. Now 3 to the power of minus 1, that will be 1 by 3 to the power of 1. And then we have division, and then 4 to the power of minus 1 will be 1 by 4 to the power of 1. So 4 to the power of 1 is just 4. The whole thing is raised to the power of 2. So here this will become 1 by 3 divided by 1 by 4, and this whole thing is raised to the power of 2. Again, you can see division of fractions, isn't it? So we know how to do division of fractions. So this becomes 1 by 3. Division changes to multiplication. 1 by 4, either reciprocal, 4 by 1. And this is raised to the power of 2. Now multiply the numerators and the denominators. 1 fours are 4 and 3 ones are 3. And this whole thing raised to the power of 2. That means we multiply 4 twice. And we multiply 3 also twice. 4 fours are 16 and 3 threes are 9. So our answer to this question is 16 by 9. Now we can also convert this to an improper fraction. Now this is an improper fraction. We can convert it to a mixed number. How? 9 ones are 9. then what is remaining? 9 ones are 9, and what is left is 7, 7 by 9. Now, if we have to do this division, this is how we quickly do it. 9 ones are 9, minus 16 minus 9 is 7. So when we write our mixed number, we write the quotient and then the remainder and then the divisor, and that's how we got 7 by 9. Question 5. Here we have within brackets 2 square plus 3 square. So that's not negative, that's positive. So we can do that easily. 2 square means 2 twos are 4 plus 3 square is 3 threes are 9. So 4 plus 9 into the square of this. 1 by 2 the whole square. So this becomes 4 plus 9 is 13 into 1 into 1 is 1. 2 into 2 is 4. 1 by 4. So 13 into 1 is 13, and in the denominator we have 4, which is an improper fraction. We can convert this to a mixed number. Divide 13 by 4. 4 threes are 12. What is remaining is 1, and the denominator is 4. So what is our answer? 3 1 by 4. Question 6. So here once again, let's work out what's given within brackets. It's a positive part, so it's easy. 5 square means 5 into 5, that's 25. Minus 3 square is 3 into 3, that's 9. Into, now here let's be careful. So remember we said when you have a negative power, you have to write it down, isn't it? Now so this is 2 by 3 raised to the power of minus 3. So this becomes 1 by 2 by 3 raised to the power of 3, isn't it? So what we do is when we are going to move this from the denominator, because it's a fraction here, when we move it to the numerator, removing the 1, we have to write the reciprocal. So 1 by 2 by 3 will now change to the reciprocal of this, which is 3 by 2. 3 by 2. So 2 by 3, we are writing the reciprocal. We have taken it to the numerator, and now this is raised to the power of 3. So let's write that there. So 3 by 2 raised to the power of 3. So this is 25 minus 9, which is 16 into, now here we have 3 raised to the power of 3, that is 3 into 3 into 3 divided by 2 into 2 into 2. So this will be 16 into 3 threes are 9, 9 threes are 27, so that is 27, and in the denominator we have 2 twos are 4, 4 twos are 8. Now we can cancel 8 and 16. 8 ones are 8, 8 twos are 16. And now we can multiply the numerators. That is 2 into 27, which is 54. So this is our answer. 54 is the answer to question 6. Question 7. Here in this question, we have fractions which are raised to negative powers. So when fractions are raised to negative powers, you write the reciprocal by changing the power to positive. So this becomes 4 by 1. 1 by 4, write the reciprocal 4 by 1, and the power is now positive. So instead of minus 3, we write 3 minus, now here we have 1 by 3 raised to the power of minus 3. When a fraction is raised to a negative power, write the reciprocal. So 1 by 3 becomes 3 by 1, and the power now changes to positive, which is 3. Then as we continue division, 1 by 6 is a fraction which is raised to a negative power. So 1 by 6 will now become 6 by 1, and this is the power will now become positive. So minus 3 will now become 3. So now 4 to the power of 3 by 1 will simply be 4 to the power of 3. 4 to the power of 3 minus 3 to the power of 3, because by 1, even if you raise it to the power of 3, it's still 1. So 4 to the power of 3 minus 3 to the power of 3, not 2, divided by, here also, instead of 6 by 1, we can simply say 6 raised to the power of 3. So now 4 raised to the power of 3 is 4 into 4 into 4, which is 4 fours are 16, 16 fours are 64. So this is 64 minus 3 raised to the power is 3 into 3 into 3. So this will be 3 threes are 9, 9 threes are 27. 64 minus 27. So this we'll put it within brackets, divided by 6 to the power of 3, which is 6 into 6 into 6. So when you multiply, what do you get? 6 6 are 36. 36 into 6 is 216. 64 minus 27 is 37, and divided by 216, we write it this way, 216. Now this can't be simplified further, so this is our final answer, 37 divided by 216. Question 8. Here we have a negative of a fraction raised to a negative power, and the whole thing is once again raised to another power. So that means here we have to apply the power law where we multiply the powers. So here this now becomes, we can write this as it is, that is minus 3 by 4. Now this we can raise it to the power of minus 2 into 2. So this is minus 2 into 2. So what does this become? This becomes minus 3 by 4. The whole thing is now raised to the power of minus 4 because 2 twos are 4, minus 4. So now we have a fraction raised to a negative power. That means we write the reciprocal of this fraction. So minus 3 by 4 now becomes minus 4 by 3, and the power now becomes positive. So this is raised to the power of 4. So now we can work this out. So minus 4, I'm taking only minus 4 raised to the power of 4. Now this is also something that we have learned. When you have a negative integer which is raised to a power that is even. Now 4 is an even number. Your answer will be positive. So if you have a negative integer raised to a positive, to an even power, your answer is positive. If your negative integer is raised to an odd power, your answer will be negative. So here the answer is going to be positive. So we'll have positive plus, now 4 times you multiply 4 into 4 into 4 into 4. So we multiply this 4 times. So this is now 4 fours are 16, 16 fours are 64, 64 into 4 is 256. So now minus 4 has now become 256. Now raised to the power down we have 3 raised to the power of 4. 3 raised to the power of 4 is 3 into 3 into 3 into 3. So this is 3 threes are 9, 9 threes are 27, 27 into 3 is 81. So here we have 256 by 81. So this is our final answer, 256 by 81. Question 9. So here what do we have? 3 by 5 raised to a negative power, which is raised to again a negative power. So here we can apply the power law where we multiply the powers. So this will be 3 by 5. The whole thing is raised to the power of minus 2 into minus 2. So this now becomes 3 by 5 raised to the power of minus 2 into minus 2. Minus into minus is plus. 2 twos are 4. So this is simple now. This is 3 raised to the power of 4 divided by 5 raised to the power of 4. So that is 3 into 3 into 3 into 3 divided by 5. Again 4 times 5 into 5 into 5 into 5. Now let's multiply. 3 threes are 9, 9 threes are 27, 27 threes are 81. So we have 81 in the numerator. Now in the denominator, what do we have? 5 fives are 25, 25 fives are 125, 125 into 5 is 625. So our answer here is 81 by 625. Question 10. So here we have in brackets 5 raised to a negative power and 3 is also raised to a negative power. Product of these two divided by 6 raised to minus 1, another negative power. So we know what to do when we have negative powers, isn't it? 5 raised to minus 1 will now become 1 by 5 raised to 1, which is 5 itself, into 3 raised to minus 1 becomes 1 by 3 raised to 1, which is 3 itself, divided by 6 raised to minus 1 becomes 1 by 6 raised to 1, which is 6 itself. Now let's multiply the numerators. 1 into 1 is 1. 5 threes are 15, divided now by 1 by 6. So division of fractions, we know how to do. 1 by 15, division changes to multiplication. 1 by 6 becomes 6 by 1. Now let's multiply the numerators and the denominators. 1 into 6 is 6. 15 into 1 is 15. So our final answer here is 6 by 15. 6 by 15 can also be reduced to the lowest term. Both are divisible by 3. 3 twos are 6, 3 fives are 15. So if you're asked to reduce to the lowest term, you can do that and get your answer as 2 by 5. Question 2. If 1125 equals 3 raised to the power of m into 5 raised to the power of n, find m and n. That means we have to find the powers. So a number is given to us. This number has been put as a product of its prime factors. As you can see, 3 and 5 are prime numbers. So these are the prime factors of 1125, but we have to find out how many times we have to multiply that to get this number. So in that case, we have to find the prime factors of 1125. So let's do that. So 1125, let's begin with 5. 5 twos are 10. Then we have 1 left, that becomes 12 there. 5 twos are 10, there's 2 remaining, 25. 5 fives are 25. Let's continue with 5 again. 5 fours are 20, and again there's 2 left, 25. 5 fives are 25. Continue with 5. 5 nines are 45. Now we can't use 5, let's use 3. 3 threes are 9. Once again we can use 3. 3 ones are 3. So what are the prime factors of 1125? Let's write that first. The prime factors of 1125 are 3. How many times of 3? 3 raised to the power of 2 into 5 raised to the power of 3. So here it's already given this way, isn't it? So let's write that also. 1125 is equal to 3 raised to the power of m into 5 raised to the power of n. This is what is given to us in the question. That means this is equal to this. So let's write that also. 3 raised to the power of m into 5 raised to the power of n is equal to 3 raised to the power of 2 into 5 raised to the power of 3. So here, since you have the equal to sign, what we are trying to say is 3 to the power of n is equal to 3 to the power of 2. That means we have found the value of m. So here it is m, 3, and the base is also the same. 3 is the base and the power is 2 here. That means we have found the value of m. M is equal to 2. Similarly, 5 raised to the power of n is equal to 5 raised to the power of 3. That means n is equal to 3. So let's write that n is equal to 3. So we have found the answers. M is equal to 2 and n is equal to 3. Question 3. Find x. If 9 into 3 raised to the power of x is equal to 27 raised to the power of 2x minus 3. Now first let's write down the question. So this is 9 into 3 raised to the power of x is equal to 27 raised to the power of 2x minus 3. Now here, remember, if we have to apply the laws of exponents, the bases have to be the same. So here we have 3 raised to the power of x and here we have 9. So the base is not the same. So let's find the prime factors of 9. So in that case, 9 divided by 3, 3 threes are 9. So and 3 ones are 3. So what are the prime factors of 9? The prime factors of 9 are 3 into 3, or we can say 9 is equal to 3 raised to the power of 2. So here, now instead of 9, we can write 3 raised to the power of 2. So this becomes 3 raised to the power of 2 into 3 raised to the power of x. Now can you see the base is the same, so we can apply the laws of exponents. Similarly, on the other side also, let's find the prime factors of 27. So 27, the prime factors, again let's divide it by 3. 3 nines are 27, then 3 threes are 9, 3 ones are 3. So here the prime factors of 27 are 3 into 3 into 3, or we can say 3 raised to the power of 3. So instead of writing 27, we can say 3 raised to the power of 3. So this becomes 3 raised to the power of 3, and this whole thing is now raised to the power of 2x minus 3. Now, since the base is the same, here we can apply the product law, which says when you have to multiply two numbers where the base is the same, you can add up the powers. So in multiplication, we add up the powers, isn't it? So this becomes 3 to the power of 2 plus x. Now on the other side, we have 3 raised to the power of 3 and the whole thing raised to the power of 2x minus 3. That means we can use the power law here. According to the power law, it is 3 raised to the power of 3 into the other power, which is 2x minus 3. So now here you can see that both sides are equal. So this is in the form of an equation. Now we can solve the equation by writing only the powers, that is 2 plus x is equal to 3 into 2x minus 3. Now let's work this out. So this is 2 plus x, and on this side we have to first multiply 3 into 2x. So that becomes 6x. So this is 6x, and then multiply it with minus 3. It becomes 3 3s are 9 minus 9. So now on the left hand side we have 2 plus x. On the right hand side we have 6x minus 9. Let's get all the x to one side and all the other numbers to the other side. So let's leave this x here, and we're going to transpose 6x to the left hand side. It now becomes minus 6x. Now on the right hand side, what do we already have? We have minus 9. We already have minus 9. We're going to transpose this 2 to the other side. So it becomes minus 2. So here x minus 6x, that means 1 minus 6 is minus 5. So this is minus 5x, and here it is minus and minus there. So the sign is the same. 9 plus 2 is 11. So minus 5x is minus 11. Now if we have to only find the value of x, on the right we have minus 11, we leave it as it is. Now we transpose this minus 5 to the other side. So when you transpose it to the other side, because it's multiplication on the left, it becomes division on the right. Here we can cancel out the minus signs. So x now is equal to 11 by 5, or if we have to simplify it further, we say x is equal to, now convert that improper fraction 11 by 5 into a mixed number. So that becomes 5 2s are 10, 1 by 5. So now we have found the value of x. X is equal to 2, 1 by 5. So with this, children, we come to the end of this exercise. Thank you, children.